Hey, good morning. I was watching a video this morning from this channel here. These two nice young people. This is one of those educational entertainment the channels. I like them. I think they're a lot of fun. Like the most famous ones, like Three Blue, One Brown. Are you really going to learn anything from these channels? I doubt it, but they're fun, and the animations are awesome. Anyway, that's not the point. The point is, I was watching this one this morning. Why tensor imposters fool so many people? And I started reading the comment section, and mathematicians are just blasting this kid. I mean, really, it's sad. Let's take a listen.
Mathematical objects are tensors and which are tensor imposters? Before answering this question, we need to define what a tensor is and what we mean by tensor impostor. A tensor is just a mathematical object that lives on a space, like spacetime or a curved surface, for example, and has a rule that tells it how to stay the same when you change the way you are looking at the space, so when you change coordinates. Think of a tensor as something whose values may change, but its meaning doesn't, no matter which coordinate system you're using. Even more concretely, say you are measuring something physical, like a force, a flow, or curvature, and hand your results to someone who uses a different map of the world, different axes, different rules. If they recalculate your values using the correct transformation rule, they will get the same physical.
Okay, so let's look at some of these comments. They're brutal. This is what happens when you leave a physicist alone without a mathematician. Tensors are multilinear objects. They're just more reference to coordinate-independent objects. A more general way to find a true tensor. There's a positive one. Never learned tensors from a physicist. The whole 19th century style definition via coordinates and indices will confuse the shite out of you. It goes on and on and on. There's another nice one. There's one I don't know what it says. Anyway, that's not the point. The point is why do we, as science and engineering, look at tensors so differently than mathematicians? I think one of the actual uses of AI is to put my thoughts down in a well-written page because I'm not a very good writer. So I asked AI to do that, and let's take a look at that. Okay, I said, why do mathematicians and physicists explain tensors so differently? Mathematicians and physicists explain tensors differently due to their different goals and perspectives. I guess I knew that. A mathematician's definition is abstract, coordinate-free, and universal, while a physicist is a more concrete, component-based, and application-oriented one. A mathematician defines a tensor as a multilinear map or an element of a tensor product space. In simple terms, a tensor is an object that takes a set of vectors and covectors and produces a scalar. Now, when I retired, I was looking for something to study that would keep my brain from rotting. I've said this many times, and I chose general relativity. Little did I know what I was getting into. Well, the language of general relativity is tensor calculus. I didn't know any, so I had to start from the beginning. What is a vector? That's where I had to start. And in doing so, I really came to like this field of tensor calculus. It's a lot of fun, and it has a lot of applications in many fields. It's not just general relativity. But let's say that I started out by this definition. A simple term, a tensor is an object that takes a set of vectors and covectors and produces a scalar. I don't know where in the hell I would have gotten. Now, here, a physicist defines a tensor by its transformation properties. A tensor's array of numbers that transform in a specific, predictable way with coordinate systems is changed. Now, even I can understand that, okay? So it depends upon your perspective and what you're trying to accomplish. Two things can be true at the same time, right? So if you are studying pure mathematics, yes, this is great for you. But if you're a science and engineering, the major, do you really need to understand this to begin with? No. This is what you need to understand. So, my point is, why do we keep arguing about this stuff when it's just applied in different ways? That's the point of it, right? that mathematics has to be very precise with their definitions of things, and then the rest of us take that and apply it to something useful in the real world. So I don't see why there has to be all this discussion about it. It's two things are true at the same time. Anyway, I thought that was fun.